Hi, period three. Sorry I'm not there today. This is the task that everybody else did yesterday, but we didn't get to meet together, so I just wanted to make sure you guys got a little video too about log logic. So this is the 2.1 task, and to start out with, it's just reminding you that remember, hey, log base 2 of x is the inverse of the exponential 2 to the x. And this is just kind of reminding you of that circle pattern of how we convert from one to the other. So if I have 2 cubed equals 8, remember to convert that to log form. It's log base 2 of 8 equals 3. If I have log base 2 of 8 equals 3, to convert that to exponential form, I'm thinking 2 to the third equals 8. So using that relationship, we know some of these facts about base 10. So if I'm looking at log base 10 of 10 should be 1 because 10 to the 1 equals 10. So what you're going to be doing in the task today is kind of more of what's right here. We've got log base 10 of 100, and then I just put equals question mark. So you're thinking 10 to what power equals 100? Well, we know that's 2, so your answer here would be 2. Okay, you can kind of see the inverse pattern where inputs and outputs switch out. So we're going to be practicing with that pattern today on the 2.1 task. This should go pretty quick. To start out with, you might want to break it into kind of two parts. The first part being 1 through 8. They're all very similar to this. Okay, so I already have the answer here for number 1, but I want to explain where it came from. So for example, if I'm looking at B, log base 3 of 9. Okay, so what I'm trying to think is 3 to what power gives me 9? And so that's what I wrote right here. Well, that would be a 2. So on the number line above 2, I'm going to put B. Okay, if you want to put a point, that's fine. But we want to try to put these different logs given, A through E, in order on the number line and approximately where they should go. And then we have C, which is log base 3 of 1/3. So I'm thinking 3 to what power gives me 1/3? Okay, so that's my conversion to exponential form. Well, that power should be -1, so C goes here. Okay. Similarly for A, 3 to the first is 3, so it goes on the number line here. D, 3 to the 0 should give me 1, so D gets placed on 0. And then E is log base 3 of 1/9, so it should be 3 to the -2, gives me 1/9. Okay, so that's the order that we should place them in and where they should be placed on the number line. However, I created this letter F, okay, log base 3 of 8. Well, we know that 8 occurs between 1 and 2 because 3 squared is 9, and 3 to the first is 3, and 8 falls between 3 and 9. Okay, so I placed it on the number line between 1 and 2. If you notice, it's a little bit closer to 2. Why would that make sense? Well, because 8 is closer to 9 than it is to 3, right? So it actually should probably be even a little bit closer. It looks too close to halfway, but that's okay. All right, so the rest of this page, most of your answers should be whole number answers, and then you get to number 5, and then you start seeing some that should be no longer whole number answers, okay? Then you get to beyond this, okay? Beyond this, we're going to look at 9 through 14, and it says, determine whether the following statements are always true, sometimes true, or never true. If the statement is sometimes true, describe the conditions that make it true. And then for all of them, you need to explain your answers. I'm going to backtrack for a minute to number 8. So just thinking about this part B, log base 5 of 5 to the -2 equals what? So I'm thinking 5 to what power equals 5 to the -2. So I set up my exponential equation. So that means my question mark has to equal -2. So B would be above -2. So ultimately, with this one, they're giving you the answers in the exponent, okay? So I also drew it right here. So anything that we're taking log base 5 of if it's also a 5 and what I'm taking, that part ends up canceling out, and what's left is my exponent. So kind of a cool property of logs. All right, I don't want to give you all the answers here, so we're going to just cover this up. But here's an example. Okay, number 9, the value of log base b of x is positive. Okay, so using evidence from 1 through 8, you should see that yes, sometimes log is positive, sometimes it's also negative and 0 though. So I said that this was sometimes true. That's what I'd like you to try on 9 through 14. Just go through and base it on logic from 1 through 8, and we will go over the answers when I'm back, hopefully tomorrow. I hope you guys have a good day, and good luck.